So it says here, let's try doing that in reverse. It says change the following mixed radicals to an entire radical form. So as you can see, we have what's called mixed. We have a number on the outside and we have a number on the inside. That's mixed. And what we want is it to be entirely inside the radical. We only want a single number on the inside. So we're trying to think, if we're working backwards, how did we get a 2 out here to begin with? Well, it must have been that there was 2 2's originally that were here, and we took both of those out as a pair and we wrote it out in front. So when we're trying to get back to the original entire radical form, we got to bring this 2 in, and we have to remember, okay, well, there would have been 2 of those numbers to begin with. Of course, there's still a 3 there. And so we can just do some simple multiplication. 2 times 2 is 4. 4 times 3 is 12. And that's it. It's entirely in the radical form. So we go over here. We look again. 3, well, if we're going to bring it in, it must have been a pair. So there's a 3, there's a 3, and there's a 4. And 3 times 3 is 9. 9 times 4 is 36. So square root of 36. Now, square root of 36 is just 6, but we're leaving it in this entire radical form. We're not actually simplifying it at all. 4. Now, 4 is kind of an interesting one. The same thing works. You can bring it in, and it must have been a pair, so we can go 4 times 4. And of course, there's still that 5 there. And we can do the math. 4 times 4 is 16. And 16 times 5, it's like, oh, I don't really know what that is. Well, maybe we could multiply these together first. 4 times 5 is 20. And 20 times 4 is 80. So it works the same way. But as you remember from the previous video, we didn't take out 4's. We would have taken out 2's. So technically, in order to have gotten a 2, in order to have gotten a 4, there would have been a pair of 2's and another pair of 2's that when they came out got us the 4. But working backwards, we're just trying to be efficient. We don't need to worry about that. When we bring that in, just bring it in as a pair. So let's go on to the next one here. I'm just going to zoom out and you can take a look. There should be 3 of them. Okay. So it says, hold on. Before we think this is just about square roots or square radicals, we could be working with cubes, which is the 3rd power. So there are some perfect cubes, things like 1, 8, 27, 64. You get these, by the way, from saying, well, what's 1 3 times? 1 times 1 times 1? Well, that's 1. Or what is 2 3 times? 2 times 2 times 2 is 8. What is 3 3 times? Well, 3 times 3 times 3 is 27. That's where these come from. But let's take a look here. What does it say? Simplify the following entire radicals to mixed radical form. So everything is entirely underneath this root symbol, this cube root symbol. You could tell because there's a 3 there. And we need to make it mixed. So the same process applies. We break this down. 16 can be 4 times 4. And both of these can be a 2 and a 2. And all we're looking for now is triples. This 3 tells us to get things into group of 3's. So I see that here. There's a group of 3 2's. So we take that 2 out. We only count it once because it's just a single group. And then we got our cube root symbol. Don't forget the cube root. It was there to begin with. And what is our leftover? Our leftover is just a 2. So that goes there. So we just had one single group of 2's, but they were in 3's. Let's look at another example here. At B, 24, we can break that down. That's 6 times 4. This is 3 times 2. 4 is 2 times 2. So I'm looking for triples. I see some triples there. So I'm going to write that out in front, just the one group, and a cube root of 3 left over. This leftover 3 gets written down on the inside. We could not take it out. It was just an extra one. So let's take a look here at question C. I'll just box this. 108. So we have to break up 108. Sometimes these numbers get pretty large, and the easiest way is to cut them in half. So 54 times 2. And 54, I know that to be 9 times 6. The 2 we can't do anything with. It's already lowest. We're just going to bring that down. 9 is 3 times 3. 6 is 3 times 2. And we can carry that 2 down. So again, we're looking for triples. So I see some triple 3s. And that's it. So that triple goes on the outside. I got a cube root symbol, and my leftovers are a 2 and a 2, so that is 2 times 2 is 4. And so we have 3 cube root 4. So we're going to try the next ones here. I think there's 3 more to try. So let's see here. Cube root of 128. Number again is kind of large, but we can break that down. 120 is 60 and 8 is 4. So we'll cut that in half, 64 and 2. And then 64 I know is 8 times 8, and I can just bring this 2 down. I like to start working a little more efficiently here, and I like to break 8 down into 2 times 2 times 2. 2 times 2 is 4, and another 2 is 8. And so I can do the same thing here. 2 times 2 times 2, and I can bring this 2 down. So I've got lots of 2's here. I just want to see if I can make any groups of 3. So I see a group of 3 there. I see another group of 3. So I got 2 groups. So 2 times 2, which is going to be 4. So I count this once, and I count this once. So 2 times 2 is 4. And then I got a cube root symbol and a 2 left over. So we say the answer is 4 cube root 2. Don't forget that little 3 that tells the reader that it's a cube root. So now, okay, now I have 750. Breaking these down can look a little tricky, but with the 0, I like to go 75 times 10. That's probably the easiest way to separate that. You could divide by 2 or by 5s, but that might take a little bit longer. The 0 helps out by making that a 10, and 75 can then go 25 3 times. And this is a 2 and a 5. 25 is a 5 and a 5, and I have a 3 left over. I have a 2 left over, and I have a 5 left over. So I'm looking for groups of 3. And it's kind of in a weird order, but I'm going to have to circle them. I see the 5s. So I have a group of 5s. I'm going to write that, just a single group. This is one 5. And the cube root symbol. And my leftovers are a 3 and a 2. So not 32, but 3 times 2, which is 6. So 5 cube root 6. And let's see what we got for the next one. Cube root of 648. Now, it might be hard to think, I don't have that trick with the zeros. So if you wanted to, you could just go pick a number like 2, or I'll just pick 4. I'll see, does 4 go into, if I can divide 648 by 4. So 4 goes into 6 once, and then I can subtract that to get a 2 and bring down the 4. So 4 goes into 24 6 times, which is 24, which gets you nothing. And I can bring down this 8. 4 goes into 8 twice, and so I get a 0. So it goes 162. So I can separate this into 4 and 162. Now 4 can split up to 2 times 2. 162, I can see that 160 will be 80. So I'm thinking it's 81 and 2. And I got 81. 81 is 9 times 9, and I can bring this 2 down. And I can bring these 2 down, these 2's down. And then I guess I just have these 9's. So this is a 3 and a 3. This is a 3 and a 3. And then I've got some 2's to bring down. And I'm going to have to circle this kind of weird. So I've got a group of 3's and a group of 2's. So a group of 3 and a group of 2. 3 times 2 is 6 cube root. And my leftover is just this little 3 here. So 6 cube root 3. So that number was not as easy, 648, not as easy to simplify. But there it is. And so now, lastly, we got to do this all in reverse again, like the start of the video. So let's try doing that in reverse. Change the following mixed radicals to entire radical form. So as we can see, like I said at the beginning, they're mixed. There's some numbers on the outside and a number on the inside, and I want to bring it entirely inside. So I just want just one number in here. I can see that there's a 3. That meant that we must have taken groups of 3 out. So when I bring this in, I'm going to have to remember that it must have been 3 3s. And of course, there's still a 4 out in front. Now I got to figure out what this is, and it's not entirely obvious. So I know that 3 times 3 is 9, and 3 times 4 is 12. So maybe I should try to do it off to the side. What is 12 times 9? 9 times 2 is 18. 9 times 1 is 9, plus the 1 is 10, so 108. So it looks like this is the cube root of 108. So just to recap that 3 on the outside, when I brought it inside the radical, it has to go as triples. Let's try another one here. 5. So it's a 5 on the outside. I want to bring that inside and make it entirely underneath the radical. So here's the cube root. And there must have been a triple 5. So I'm going to write that down. Triple 5s. And of course I still have my 2. So we can look at how to multiply this. Sometimes when there's 4 numbers, I like to multiply 2 together. So I can multiply 5 times 5, which is 25. And 5 times 2, which is 10. And I can multiply those. 25 times 10, well, that's just 250. So actually, I can just write that as 250. Now don't forget that cube root symbol. Let's see what the last one is. The last one is a 4. So the same thing applies. When I bring this in, I'm going to bring this in as a group of a triple group of 3 4s. And a 5. Now, thinking about how we would have got a 4 to begin with, it would probably have been that there was a group of 2s that we brought out, and another group of 2s that we brought out to get 4, plus the additional 5 left over. That's probably how we would have done it, but working backwards here, most efficient way would just be to bring in 4 3 times like I'm doing there. Again, I don't know the most efficient way to do this, multiply all these. So 4 times 4 is 16. 4 times 5 is 20. So, 16 times 2 is 32, and then the 0, so I'm thinking it's 320, but we can do the math. 0 times 6 is 0. 0 times 1 is 0. The next line, you start with a 0. 2 times 6 is 12. Bring that up. And 2 times 1 is 2, plus the 1, which is 3. So yes, 320. So this would be the cube root of 320. So that's it for this. We've done working in reverse twice, once at the beginning and once at the end of the video, and then in the middle there doing the cube roots, bringing things out in triples.